expertise. I'm actually just curious because I appreciate your knowledge on it. From my understanding, there's two mutually incompatible theories of snake evolution. From my understanding, some say that they evolved from water reptiles, right, mosasaurs,
yeah.
or others say from burrowing lizards. Like, which one do you hold to?
There's a reason it's very controversial.
That's it. Look, I talk a lot. You can take your time and you can have the floor and explain.
I personally suspect they were burrowing animals, much the same way that lizards these days are losing limbs and becoming very snake-like, and they're burrowing animals.
What would the people or the evolutionists that hold to the theory of, because you said that you believe that they evolved from the burrowing lizards?
Again, it's a controversy because nobody really knows. But from what I know, I would go 60-40 in favor of burrowing.
You would, okay. And then the ones that hold to the theory that maybe they evolved from water reptiles, right, the mosasaurs, like what would be their disagreements in regards to the burrowing lizards?
I think it's very much lifestyle, and you do also find a lot of fossil snakes that were aquatic. Najash, for example, I believe was. Oh no, not Najash. I can't remember. There's all the Latin names, and all rather complicated. But there are a few fossil snakes from very early on that were aquatic.
Okay, so. So you hold to the theory that they evolved from burrowing lizards then?
I don't hold to it.
Okay, I get what you're saying. So like you would see the evidence 60-40 leans more towards that one?
Personal opinion, yes. There'll be a lot of people that disagree with me, but that's what I think.
Okay, so we know, and I don't have to go over all the differences, but we know snakes are very different from lizards. What kind of mutations would you say were responsible for transforming those burrowing lizards into snakes?
Well, the things that really define snakes is not leglessness, because obviously there's a lot of lizards that are legless that you don't call snakes. Most of the differences you'll probably find are in the skull. They've got quite a derived skull compared to a lizard.
Right. And the jaw hinge, like I know snakes have fangs and a flexible jaw hinge, whereas lizards have, I think, flat teeth and immobile skulls, right?
Yeah, the snake's skull, it's separate on the lower jaw and it spreads out. A lot of people think they dislocate, which is complete rubbish.
What about like the fact, like with movement, for example? I know lizards move by, I think they twist their stiff body or even use their legs, but the tails of snakes are totally different. They're short and they don't break off when grabbed. You said you own a few snakes, you would know that. In comparison to lizards, they've got the longer tails that can break off if another animal grabs it.
Only some lizards.
Pardon?
Only some lizards.
Only so some lizards would they be more comparable in tails to the snakes?
Geckos, for example, are a group that can drop their tail.
But they're still far different than like snakes. They use their tails are short. They're mechanically far different than you said geckos?
You get short-tailed lizards as well. Just look at the Uromastyx, for example.
Right. So you're more so looking to like the skull morphology and things like that versus what
defines snakes from lizards is mostly in the skull.
Is mostly in the skull.
Yeah.
Because I know like snakes, don't they move? Since we're on movement, don't they move by gliding and they use the bottom scales on their body?
There's a lot of different ways that they move around. Some of them have the S pattern that you see in popular TV, and that they move their body from side to side in order to have forward motion. Some of them move almost like in a straight line by movements of the ventral scales and the muscles below them. And then you've got things like the sidewinder, which just fling themselves. There's all sorts of different motions for how snakes move.
Don't like one that I'm curious about, like for example, not only do snakes have fangs and a flexible jaw hinge, where the lizards, as we were discussing, have flat teeth and immobile skulls, but you're saying it's in the skulls that we would look at for the defining features. We know some snakes have heat pits on their nose, but then they also have no external ears. Lizards, on the other hand, lack heat pits, but they do have external ears. Like, how would you explain that difference? Is that something that just evolved over time that we can see in the fossil record, or is that something that's inferred to have evolved?
Well, you mentioned that only some snakes have the heat pits. So you've got snakes that don't have heat pits. For example, all the snakes I own, none of them has any heat pits. So I don't see where you're trying to go with heat pits.
Well, I'm just, I guess, going over a lot of the, because even if like some snakes may have this and some don't, or with lizards, with the tails, some may have a shorter one, but there still are these defining features that would need to be explained evolutionary wise, how that burrowing lizard evolved into a snake as we would know today. And it seems like a lot of the evidence, especially from the fossil record, involves things that are lost, right? Legs, for example. So my question would be, how does loss of genetic and anatomical structures to you provide substantial or sufficient evidence for that type of evolution that would say burrowing lizards evolved into snakes over time?
Well, could you repeat that in fewer words, please? I'm trying to get the point of your question.
How does loss of genetic and anatomical structures provide evidence for lizard to snake evolution?
How does loss of genetic information provide evidence for lizard to snake evolution? Is that what you're asking?
Yes.
Well, that's not really the thing we looked at when we said that snakes were derived from lizards. We didn't look at genes and say they've lost genetic information, therefore they evolved from lizards. It's different things.
I know, but what I'm saying is, in the fossil record, for example, what we look at is snakes. You're saying that they evolved from lizards, but then the fossil snake species we see that actually have like those, I guess, hind legs, you could say. It looks like the further back, the furthest back you can go, the snakes you find, they don't have any legs. And then you can find some snakes with legs 50 to 100 million years later.
Yeah.
And then, but it should be like the reverse. Like, why, I guess, based on your reasoning, and because I imagine that the differences we're talking about and how those changes would be required, we can infer from the fossil record. But snakes, so you're saying snakes would have gain legs, and then like I see reversals in the fossil record. Like, how do you explain that?
This is a fundamental misunderstanding of how evolution works. You get a population of snakes. Now, the original snakes would have had legs because, as I mentioned, leglessness isn't the defining characteristic of snakes. It's in the skull. So the original snakes would probably have had legs. You would then have the divergence of these big groups of snakes. You find it when there are adaptations, there's usually radiation where you get masses of groups of these animals and they spread across large areas of land, maybe even across the globe. So back millions of years ago, say 200 millions of years ago, you probably would have had snakes in various parts of the world with legs. Over the next millions of years, some of those groups of snakes would have lost their legs. Some of those snakes might have been fossilized, and that's like the ones you see in the fossil record. So you've got legless snakes showing up in the fossil record. You've still got snakes with legs living elsewhere in the world that either went extinct later on or lost their legs later on. And you still get some of those legged snakes moving on through the years and to the point where, say, 20 million years ago, you still had snakes with legs. It's not... the snakes didn't all evolve as one single population. The snakes would have radiated as snakes with legs into multiple populations. Some of them would have become legless long before the others, or some of them may never have stopped being legless and just gone extinct and left only the legless snakes. So to have the earliest fossil snakes we find to be legless and some legged snakes to be found later on in the fossil record isn't a problem at all.
Right. So it's just because my point is, like, according to our model, of course, and as I've said many times, it's genes that are inherited. I think genes is where we can directly determine, what's related, what's not, the origin of these traits in regards to, let's say, the lizards to snake evolution. We do see snakes with no legs. We see snakes with the the hind legs, for example. But according to our model, those layers. Yeah, those layers are not, they are not absolute ages of time. So it looks like the evidence would suggest, yeah, either the snakes with the hind limbs are used, as we can see today, for copulation, reproductive purposes. I think for clasping during reproduction. Like, would you agree with that function, or would you say that they're completely worthless, the hind legs?
Trying to think, because there's quite a lot of groups of snakes that still have it, and I believe it varies between species.
Because I'm trying to, like, the ones you see with hind legs in the fossil record, they could either be, like today, used for reproductive purposes as a function, or like, for example, Najash, is that the name of the
two-legged snake? Yeah, it's got two hind limbs.
Isn't that and that's a genus of snake, right? Najash, yes. Like there's many species in that genus.
Yeah.
So that snake has the hind limbs on the side of its body, though, right? Versus it's coming from the side of the body, isn't that? I remember you pointed that out before.
Yeah, that's you won't find lizards with legs below. They're always
right.
Side.
Right, and that's like a defining trait in that in the fossils of the genus Najash that you would point to that say, okay, here's your two-legged snake. That would be your transition between your burrowing lizard to your snakes with legs.
Not necessarily, no. Because as I said, leglessness is not the definitive characteristic of snakes. It's in the skull.
Right. Are you familiar with I think it's the HA1 gene for back legs? It's in a non-functional or degraded form in snakes. That's why sometimes you can see snakes that are born with these useless legs that don't actually function, because that gene is broken, suggesting that there were some species of snake in the beginning. Like according to the Bible, right, the serpent was cursed. And that serpent would have had legs. And if God, through epigenetic purposes or just, the damaging of genes, like we see with this HA1 gene, it was a process over time that these snakes would lose legs based on the degradation of that gene, for example. I mean, that's consistent with our model of snake species with some legs like Najash, for example, that have lost them over time, and snake species like the furthest snake species we can see in the fossil record that have no legs at all, or just basic hind limbs that sometimes evolutionists will say are vestigial, but they're actually used for reproductive purposes. So that would be, I think, pretty consistent with our model. Take your time. Yeah, go ahead.
It's interesting what you brought up there. So God would say, be gone with your legs, snake. How did it work there? Was it instant or was it over time?
Good question. Yeah, I'm proposing theoretically that it was over time, because you can see that specific gene for legs, for the back legs, is degraded, and it is in a non-functional form. So if God, because it says God cursed the serpent, so if those genes were, because you've got Garden of Eden, you've got the serpent, but you've got also outside the Garden of Eden, you've got snake species that theoretically, like Najash, would have the hind legs, that they would lose them over time. Yeah, I don't think they lost them right away, no.
Do you think all the fossils of snakes were caused by the Noah's flood?
I would say that the majority, like for example, the ones that are found 100 million years ago or 150 million years ago, for example, like with Najash. What's Najash? 100 million years ago that they've discovered that one? Because you would say that snakes evolved from lizards 200 millions of years ago, right? Was it during the Jurassic period, maybe?
It was around the Jurassic, yeah, I believe.
Yeah, okay, so let's say
the oldest fossil snakes we have are that long, but the genetics, goes back further, obviously.
Yeah, okay, yeah, then yeah, they would have been fossilized during the flood. That's right.
So there are some snakes in the fossil record that have legs. Some have 2 legs, some have 4 legs, some have no legs. So after God punished them, some of them lost their legs at quicker rates than others.
Yeah, that's right. Because I'm saying that God would have cursed if they're going to lose their legs, and we see that there's this gene. What is it? The HA1 gene, I think it's called. Hope I'm not butchering that. I can look it up, but that is in a functionless form in snakes. We can see that today, sequencing their genetics. The snakes we see in the fossil record, they're just bones. So we can infer the best we can, but we don't have any genes. We don't have a bone. Like I said, it's not passed on sperm and egg. I think that's an appropriate inference that there would have been snakes with legs at creation. We see that the serpent had legs, and he was cursed. If it was a genetic curse where over time, and like you said, yeah, maybe some snake species lost it faster than some based on environmental conditions, because we know that a lot of change is environmentally dependent. So I think that that's perfectly consistent. Yeah.
Were certain lizards cursed as well then?
Good question. Yeah. So over time, we can see that there's certain lizard species right now. Are they the skinks, for example? I believe that they are burrowing lizards and they are losing their legs.
Yeah.
Yeah. The thing is, the curse at the very beginning of creation in a world with no accumulated mutations versus today in a world with accumulated mutations, legs, as you've said, or fish. Blind cave fish, they would be prone to losing traits or features such as that. So yeah, I would just say that loss of anatomy, loss of genetic information is consistent with our model of genetic entropy and reductive evolution.
I will say it's hardly a curse though, because snakes are one of the more successful species on the planet. Their leglessness has allowed them to take advantage of a whole host of environments. They can be arboreal, they can be terrestrial, they could be subterrestrial, they could be aquatic. Their leglessness has allowed them to radiate to loads of different areas, and they're very widespread. Would you still consider it a curse, even though that's the case?
So would you like, in your next life, would you like to come back as a snake that has to crawl around on its belly eating dust all day?
Well, they don't eat dust.
Okay, well, answer the question though. Would you? Okay, well, is there a disadvantage at birth when you get that snake that is just born and has to crawl around on its belly? I mean, in the world of predators and things like that, isn't there a disadvantage there? I mean, I agree with you that any kind of species is going to be able to learn to adapt to its environment, of course, and you can even see that in like Lenski's bacteria, for example. But when those bacteria are adapting to their artificial environment as well, and yet we can see that they're doing it through lots of function, lots of traits, lots of information. So I mean, yeah, I'm not against adaptation if that's what you're getting at.
To answer your question, if I was a snake, I wouldn't mind, because that's how snakes live.
Right. Okay, go ahead. Because you're a herpetologist, I wanted to give you some considerable time discussing snake evolution. I mean, that's your field. But I did want to go back to